Hello, everyone. Welcome to the What's New in ONAP Casablanca webinar. And in the next 30 to 45 minutes, we will go through an overview of what are some of the new changes in this latest ONAP release. Just a quick background about me. I'm with a company called Arna Networks. We provide products and services around ONAP. I am an author of 2 books, Understanding OPNFV and ONAP Demystified. I have my areas of interest include OpenStack, Ceph, data plane acceleration technologies. And prior to Arna, I was at Mirantis, Seagate, Philips, HP, and I have a master's in EE from UC Berkeley. All right, so the agenda. We are first going to give a quick ONAP introduction. Then we'll look at some facts about the release itself. What are the highlights? We'll go into a deep dive and then look at what's next. So this, if you had attended the What's New in ONAP Beijing, the last webinar, we spent much more time on just talking about ONAP because the assumption was that ONAP was new and people were not familiar with it. This time, we are not going to spend much time on what ONAP itself is. We are going to talk a lot more about the release. So if you are interested in what ONAP is, you can go to arnanetworks.com, and under resources, you'll find a couple of presentations. One is What's New in Beijing. That gives a lot deeper discussion on what ONAP is. And then there is another talk that I had given in Istanbul for a 5G event, which also gives a pretty comprehensive overview of ONAP. So feel free to check those out. So with that, let's jump into an ONAP introduction. So first, it's important to look at what ONAP does. So this is the ETSI architecture, the ETSI NFV architecture. And we are going to actually modify it a little bit. So this box here you see is the classic ETSI architecture. And on the right-hand side are some additional components. So what ONAP provides, it includes the NFV orchestrator functionality that is described in the Mano box. It includes VNF managers. And then over and above that, it includes the additional components. So it includes a unified design studio. It includes a complete service assurance and automation framework. And it includes an SDN controller, which can be used for WAN connectivity and data center underlay connectivity. So again, we are not really here to discuss what ONAP is. So I'm just going to sort of leave it at that. And you have access to those other resources if you want to learn more. All right, next we are going to go through a deeper discussion of the ONAP architecture and block diagram. In the Casablanca release, there were 30 approved projects. And I'm not going to go through all of them in great detail, but suffice to say that there's a design time and a runtime. So those two are cleanly delineated in ONAP. And in design time, the expectation is that designers, product managers will come and sort of do their design work and then hand off to operations on the runtime side, and the runtime can work independently. So we are not trying to create silos, but what we are trying to do is we are trying to give individuals the ability to work independently without depending on other people. So that's what this delineation between design time and runtime achieves. Design time, there are 2 tools, and we'll look at what's new in these 2 tools. SDC, that's used for designing, onboarding a variety of artifacts and designing network services. And then CLAMP, which takes closed loop templates, which actually I failed to mention are designed in SDC. It takes those and then configures them. So that's the combination of SDC and clamp. There are other design time tools, but we are not showing all of them. You can, if you're advanced, you can, for example, edit some of the data graphs of the various controllers. You can um, edit the other things as well. So this is just in a sort of a high-level summary. On the runtime side, for service orchestration and lifecycle management, the main component is service orchestrator, SO. And then the SO interacts with 4 controllers underneath, depending on what you want to do. So it has VFC, which is used for orchestrating Tosca-based network services and VNFs. AppC, which is used for configuring and managing the lifecycle of VNFs, layer 4 through 7. SDNC, which is responsible for the network configuration for WAN and data center underlay. And it can also be used for configuring layer 1 through 3 VNFs. And multi-VIM, which actually now has a new name, multi-cloud, which is used to interact with the VIM layer, which can interact with OpenStack and in future other clouds. So that's the service orchestration and lifecycle management side of the house. Then for service assurance and closed loop automation, you have DCAE and policy. So DCAE is data collection, analytics, and events. All events, alarms, metrics, logs, everything that needs to be monitored should go to DCAE. And DCA is a big data platform based on Hadoop technologies. So it can scale, to the degree you want. And once analytics applications are run on that, the results of that go to the policy engine. The policy engine makes a decision on what to do, and then directs either the SO or one of the controllers to take action. So that's what forms a closed loop. Of course, you can also do an open loop and open a ticket, but the desire is for 100% automation with no human intervention. Then you have ANAI, which is active and available inventory. And that's the master sort of database that keeps track of all available and active resources and also tracks the hierarchy. So you can track all the way from a VF to a network service and et cetera to see relationships. So those are the main blocks. There are a variety of common services, supporting projects. You have something called the ONAP Operations Manager, which as ONAP itself is a cloud-native application, it needs somebody to deploy and manage its lifecycle. And it can't do it for itself. So OM installs, configures ONAP, and then manages its lifecycle. It's based on Kubernetes and Helm. And ONAP itself is containerized. And then at the top, you have API, CLI, and GUI to interact with ONAP. So that's ONAP in a nutshell. Again, if you want more detail, you can hear some of those other presentations. Now let's get into the Casablanca release. So the ONAP Casablanca release is the 3rd release. It came out in November, and the marketing release was actually in December. So it's about a week old. And what you see is the list of contributors for this release. So you see a fairly even distribution, which is what I like to see in open source projects. It's not heavily dominated by one player. There's diverse participants, and it's a very active project. You see that maybe the top 5, if we just go through the top 5 contributors, it's AT&T, Huawei, Amdocs, ZTE, IBM. What's also noteworthy is the level of participation from operators. So you see, in addition to AT&T, you see Bell Canada, you see China Mobile, Orange, Verizon, Deutsche Telekom. I don't know if I missed anyone, but so you see fairly active participation by operators. All right, so now we are going to go take a deeper dive into what exactly is in this release. So let me just give a second for the slide to update for on your side. So there are three main updates in Casablanca. First, blueprint updates. Second, new functionality. And third, something called S3P. So let's go through each of these categories. So blueprint upgrade. ONAP has a concept of blueprints. These are use case demonstrations that are developed by the community in sort of the open source community. There are two reasons for this. Of course, ONAP can support any use case. There's no limitation. But by showcasing a specific use case, the community is achieving two things. First, it's giving something concrete to operators that they can use, they can try out, they can set up a POC, they can see how ONAP works. And second, they're providing input to the developers, to the contributors, in terms of how they should prioritize their feature sets. So if a feature set is used for one of these blueprints, then it should be prioritized higher, if not lower. So it gives some sort of a guidance. So up until Beijing, there were three blueprints already. There was a virtual firewall / VDNS, somewhat of a simple use case, just to sort of try out ONAP. And once you install ONAP, you can run this blueprint to make sure that the installation is valid and correct. The next two are more sophisticated and complex blueprints, residential VCPE. And that's where you take your VCP at home and you split it into a bridge residential gateway and a virtual gateway that resides in the cloud on the operator side. And this blueprint shows how you can do that. It has many VNFs. It has multiple network services. It's a real life use case that operators can try out. The next one is VoLTE, voice over LTE. It's a combination of virtual EPC, virtual IMS, and two network services. So again, a sophisticated, complex use case. This is different than residential VCP in that VoLTE uses proprietary VNFs, while residential VCP uses open source, sort of fake VNFs. So you get to see both pure open source and commercial. So that also, I think, is a good balance. So these are already available. They're available in Casablanca as well. But over and above that, Casablanca kicked off two new blueprints. And I use the term kicked off because these are not complete. These were started, but they are multi-release blueprints, and they'll be finished by, say, Dublin or El Alto or some subsequent release. So, but let's look at them. At least there's a good start. So the first one is a cross-domain, cross-layer VPN. For short, it's called CCVPN. And again, I noted as Casablanca and beyond, so don't expect that, all the I's are dotted and T's crossed. It's really sort of a work in progress. This is for network as a service. So if you're an operator, you are seeing tremendous demand for high bandwidth flat OTN network as a service. You're also seeing demand for that network as a service to span multiple operators. So it could be, hey, I want to have a network connectivity sort of across the world that spans multiple operators. So this blueprint shows that. It shows network as a service across multiple domains by using OTN controllers, and multiple operators by using SD-WAN. And of course, when you have multiple operators, you have multiple instances of ONAP. So it also shows ONAP peering across CSPs. Across layers, they use L2 encapsulation using E-line type services. There are some VNFs inserted in that service. For example, VCP, Virtual Gateway. There are also controllers, OTN controller and SD-WAN controller. So these are all proprietary. And ONAP acts as sort of the global orchestrator, and ONAP's SDNC controller acts as an OTN supercontroller. So that's the CCVPN service. I think it's very exciting because of ONAP peering. It uses an API that's aligned with MEF interlude to accomplish this. So next, let's look at the 5G blueprint. So 5G is much more of a multi-release activity, and Casablanca just really kicks it off. So you will see a lot more concrete implementation in Dublin, El Alto, etc. So 5G, of course, is a huge topic. It's not like it's one single blueprint. And there are three sub-activities under the 5G blueprint. First is orchestration and lifecycle management of RAN, radio area network, which really requires PNF support. So what we expect is that in a RAN, you will have some physical components just for performance, etc. reasons. You just can't virtualize everything. So for that reason, you will have a hybrid VNF plus PNF environment. And with that, it becomes very important for ONAP to be able to manage the life cycle of PNFs in a manner similar to VNFs. Otherwise, what you have is unmanaged PNFs, or you have to have some other way to manage them, and that's just really complicated. So this provides a seamless way for ONAP to handle both. So that got kicked off. Then the next area is something called network optimization, which is a bundle for many subtasks. So with 5G, you will have real-time analytics. So in ONAP, there's a new collector for real-time, high-velocity analytics data. It's based on Google protocol buffers. So that's a new addition. There was a big body of work, and it sets the stage for monitoring 5G networks. In addition to real-time analytics, you also need bulk analytics, because 5G will emit file type data. That's a lot of bulk data. So that is also supported in Casablanca. You need more sophisticated homing. So homing is the concept of putting the VNF in the right cloud region. So with 5G, there'll be thousands, if not tens of thousands of edge locations. So you have to be sure that the VNF is being placed in the right edge location based on a variety of requirements. It could be subscriber requirements, it could be hardware acceleration requirements, etc. And that is being addressed. Scaling and healing, and finally, edge automation. So again, with so many edge locations, the registration of those clouds, etc., has to be fully automated. You can't really have someone manually configuring 10,000 regions into ONAP. Next is network slicing. This is much more in sort of a planning phase, and you will really see implementation come out in Dublin and beyond. And that's to create an end-to-end slice, to configure it, and then to optimize it in response to various conditions. So in short, this is going to be a very powerful blueprint, and just watch for it over the subsequent releases. And I think in 2019, this will become pretty solid. Additionally, there are some other features, I would say. They're called blueprints, but they're really more features of other blueprints, and they have all been enriched in Casablanca. So scaling in Beijing was manually triggered scaling, but Casablanca now supports automatic scale out as well. So for example, the closed loop automation discussion we just had, a policy engine could trigger an automatic scale out of a VNF, and it's shown with the VDNS for Casablanca. Change management, if you want to update or upgrade your VNF, that was initially supported in Beijing. So more work has been done in Casablanca. There's something called a workflow designer, which we'll get to in just a minute. That'll give additional control on the composition of workflows and really allows designers a way to construct change management workflows independent of ONAP release cycle. So previously, you had to wait for the next version of ONAP to get your functionality. Now you can change the workflow whenever you want. There's a new lifecycle management feature in AppC called distribute traffic, which helps with traffic migration before an upgrade. This is shown with the virtual firewall. There's some very early PNF support. You also want to do change management on PNFs. And there was a demo of 5G at ONS. And then change scheduling. In certain situations, you don't want to just upgrade anytime. You want to schedule that change. So with coordination with the OF project, you can do that. Hardware platform awareness. The idea is there are a lot of enhanced platform awareness features provided by hardware platform vendors such as Intel and ARM and others. And if you've written this wonderful VNF that takes advantage of these features, but if the VNF does not get orchestrated to a cloud that has that functionality, then what's the point? You've not really gained any benefit. So through HPA, a VNF that needs certain hardware functionality is placed on the right cloud region. In Beijing, policy-driven approach was shown that interoperated with heat-based VNFs. In Casablanca, a model-driven approach is shown that works with Tosca VNFs. This is shown with VCP. So the entire VCP blueprint now is available in Tosca as well, in addition to heat. And the Tosca-based VCP shows model-driven hardware platform awareness. And the final one is cloud-agnostic intent-driven homing policies. So you can, of course, say, I want 2 vCPUs and so much memory and so much disk. But you can also say that here's my QoS requirement for my VNF, sort of intent-driven. And that intent ultimately be translated to hardware requirements. And that's just a more intuitive and easier way to specify what a VNF vendor needs. And that's shown with the vFirewall VDNS blueprint. So now let's go to new functionality. And the Casablanca release has really a ton of new functionality. It's in 4 categories. So I'll wait for the slide to show up for you. So the 4 categories are design, orchestration and lifecycle management, service assurance, and then just sort of other things, so interfaces and other items. So in design, there have been changes on SDC, CLAMP, VNF onboarding related projects, orchestration and LCM. There's major updates on SO, AppC, SDNC, VFC, multi-cloud, and the ONAP optimization framework, OF. Service assurance, there's updates to DCAE, policy, ANAI. ANAI cuts across multiple, but I sort of just put it in service assurance. And then interfaces and more, you have changes to external API, CLI, VID, UUI, portal, and the OOM project. So let's go through all of them systematically. And I'll try to go through it quickly so we finish in, say, about 20 minutes or so. So with SDC, there are 2 new dashboards available. So the first is DCAE Design Studio. And the DCAE Design Studio is used for creating closed-loop automation templates. So what you can do is you can define and configure DCAE monitoring flows by assembling microservices. And like I said, it's used for closed loop or open loop monitoring flow models. The second dashboard is Workflow Designer. This is for SO BPMN workflows. And these workflows can do anything like VNF software upgrade, VNF configuration change, VNF scaling. And as I mentioned in a previous slide, previously designers had to wait for a new version of ONAP for a new workflow. But now with this, they can do it on the fly. The next update is to clamp, bring a closed loop template that has been created in DCA Design Studio. So the DCA Design Studio creates the template, and then Clamp can configure it. But this particular dashboard is slightly different. It's a dashboard to view events during runtime. So it has to do with runtime, and you can view DMAP events, you can view other events, and you can filter and analyze these events. And this is very important for things like when you're debugging a closed loop. If you don't know why a closed loop isn't quite working the way you want, now you can watch those events on DMAP. You can see what the WES collector is sending to DCAE. You can see what DCAE is sending to policy. And you can see what policy is sending to SO or one of the controllers. There's also AF integration for improved authentication. VNF onboarding related projects. So there are 3 projects that are related to this: VNF SDK, VNF requirements, and VNF validation program. In Casablanca, there was a VNF test platform creation that was completed. Integration with OPNFV dovetail was done, and really what this does is it sets the stage for the upcoming VNF compliance verification program. There are some additional tests for Tosca and heat-based VNF descriptors, so just more testing to make sure that a VNF complies with ONAP. And the VNF requirements document is very detailed. I would encourage you to look at it if you have not. It's in docs.onap.org, and it's in 5 sections. You can see the descriptions. I don't need to read through them, but it's quite elaborate. So now jumping to service orchestration and lifecycle management projects, SO. There's a new internal microservices architecture. There's support for PNF orchestration, going back to the 5G blueprint. And there's some new scale-out functionality. There's also monitoring of SO that you can do, so you can see what BPMN workflows have run and what are running. So these are some of the main features in SO. Next, ABSI and SDNC. In ABSI, there are new lifecycle management features that are now supported. So for example, reboot, hard and soft reboot is supported with support in CDT as well. So CDT is used for configuration templates, and that action is supported. Distribute migrate action is supported as well to migrate traffic from one VM to another. And that's, of course, as we discussed already, very useful for upgrades and change management. SDNC can now support geographic redundancy with automatic failover across regions using an active standby model. And request resolution to primary ODL server is done via core DMNS. There's also site health and switch messages that are sent via DMAP. So if you switch from one region to another, that message is sent via DMAP. The VFC project supports PNFs as well for the 5G use case. There's HPA support. So the Tosca-based model-driven VCP blueprint that we talked about also needs to work through VFC. So VFC now has HP support. VFC supports the ETSI Sol3 standard. So when it needs to interface to external SVNFMs, there's no driver required. There's also some internal architecture improvements to separate the state from other microservices to improve stability and lifecycle management. Next, the multi-cloud project has improved integration with SO, and this simplifies onboarding of edge clouds, which is, as we already discussed, very important for 5G and also for multi-access edge computing, MEC. Casablanca supports OpenStack Okata and Pike, and then Wind River Titanium Cloud R5, plus VMware VIO 5.0. There's experimental support for Microsoft Azure and Kubernetes. And with Kubernetes support in subsequent releases, ONAP will be able to support cloud-native network functions, or CNFs. And then the last project we are going to discuss in the lifecycle management, service orchestration and lifecycle management category is OOF. And as we saw, OOF is very critical in homing, to make homing decisions. And there's been a lot of improvements onto the homing capability. So you can do homing decisions in parallel, which improves performance and reduces the latency. And there's also, separate from the homing feature, there's also change management scheduling capability, so you can schedule your change management. Again, something we discussed earlier. Next, let's move to service assurance and automation. DCA is one of the main projects in that category. To supplement CDAP, there's now early support for Panda, panda.io. Panda.io is another Linux Foundation project. It's for analytics. It's, in some sense, you can think of it as similar to OPNFV, in that it integrates a variety of upstream big data projects and provides clean reference architecture that can be used for networking applications. So we saw some early integration, and full integration of Panda is expected by the Dublin release. Next, there is a tremendous amount of work that was done on the collector side. So as we discussed already, there's a high volume WES collector with new encoding, Google protocol buffers. And this is to support the 5G real-time analytics use case. There's a new version of the VNF event stream WES collector standard. There's PNF registration handle for to support PNFs for the 5G use case. SNMP trap collector, although PNF doesn't have to be just for 5G, it can be for other things also. SNMP trap collector to support SNMP. Data file collector, this is for the bulk use case we discussed earlier to collect files. So just a ton of new functionality on the data collection side. The benefits are DCA now enables a wide variety of big data technologies, supplements CDAP with Panda, new data collection capability to enable 5G, real-time, PNF, and bulk. And you can now support legacy PNF or VNFs, and that's what XNF stands for. XNF means either PNF or VNF. Event collection via SNMP. The next big block in the service assurance automation category is policy. So with policy, there's many new things. There are guard policies to support autoscaling and blacklisted servers. There's support for new control loops for CCVPN to do SDNC reroute action. There's a 5G OOF PCI control loop for SDNR modify action and SOVF delete action. There's improved AAF integration for authentication, and there's performance testing. And now policies can be distributed through SDC. So it's just overall just a huge set of changes to support a larger set of use cases through new guard and active recipe policies and control loop coordination, and just a lot of improvement on ease of use, stability, scalability, and performance. For ANAI and its related project ESR, external, I believe it's external service registry, to register external elements such as OpenStack, SVNFMs, EMS systems, etc. So the combination, in combination, now they support SRIOV-based VNFs. So now you have a broader set of EPA features. The ability to access historical data of what changed when. So you can now do audits and improved authentication through integration with AF. Okay, now switching to the last category, which is external APIs and other things. External APIs, there's a lot of interest in ONAP to continue aligning to TM Forum and MEF. So there was increased compatibility with both, especially TM Forum in the area of service order, MEF in the area of Legato, which is the northbound API, and Interlude, which is east-west. And the CCVPN blueprint integrates with, it says northbound, but it actually should say east-west. It should say east-west. So it's aligned with Interlude to demonstrate end-to-end operations through APIs. And these improvements just make it that much simpler to integrate ONAP with OSS BSS, so that operators don't have to have different ways, different sort of initiatives to integrate with different orchestrators. On other user interface areas, CLI now allows remote execution of commands. The CLI is inspired by OpenStack CLI, which is quite nice and usable. And the ONAP CLI is getting there. And I think I personally feel it's a lot easier to use than the API. So I would encourage everyone to try it out. VID, which is the operational GUI, operations time GUI, now gives you the ability to initiate scale out of VNFs, initiate change management for VNFs, and also supports PNFs. And you can have a network service with a PNF, and you try to deploy it. And if the PNF is not online, that's okay. It'll wait till the PNF comes up, and then the instantiation continues. Improved integration with AAF for authentication. UUI, which is another operation time user interface. It's a little bit higher level than VID and easier to use, but you lose some of the granularity of VID. So UUI adds features to support the CCVPN blueprint, network service lifecycle management, VFC package catalog, so it can now show you what packages are on the VFC catalog. And the portal has improved authentication, some other changes, and the main one being support for internationalization. So it'll be a lot easier to create portal applications in different languages. Next, OOM. OOM, again, is the project that installs, configures, and manages the lifecycle of ONAP itself. So ONAP is containerized, and then OOM uses Kubernetes and Helm to accomplish its task. So many updates. There's a central chart repo eliminating the need to build local Helm repos. There's support for pluggable persistent storage, support for Gluster file system, CPU and memory limits in Helm charts, node selectors. So gives the operations person, whoever is installing ONAP, more granularity in where to place the pods. Common shared Helm charts, for example, databases, just streamlining the installation process, and then backup and restore of the entire Kubernetes deployment. So just overall simplification, more control, broader range of storage options, improved platform resiliency. So this project continues to make progress. All right, so S3P, this is the third bucket of what's new in Casablanca. So what is S3P? So S3P is scalability, security, stability, and performance. That's where S3P comes from. But it's not just that. There are 4 more things in S3P: manageability, resilience, usability, and documentation. So Beijing was, I would say, primarily about S3P. Casablanca has also improved S3P dramatically. It's just that there was so much new functionality that we talked about that first and then S3P. There's a new logging project initiative called Post-Orchestration Model-Based Audit, POMBA, and other logging improvements. So what POMBA does is it now allows you to audit what you had designed and what has been deployed. Does that match? There are improved versions of upstream projects. ODL has been upgraded to Oxygen, and Oxygen, of course, supports P4. Kafka has been upgraded to 0.11, and that provides the data router functionality. So in addition to messages, now you can also send data over DMAP, which of course is based on Kafka. Additional improvements, SO, we already talked, has a new microarchitecture. VFC, we already talked. ANAI supports VNFs with SRIV. We covered that. AAF is now supported across multiple projects for improved authentication. We looked at many projects in terms of AAF support. Policy portal project improvements. Istio integration in MSB. So this is quite interesting. With Istio, you now get service mesh functionality, which gives a lot of improvements in the S3P area. And then advances in the music project. Music aims to provide 5 nines of service availability, even if you have 3 nines of underlying infrastructure availability. And the magic, of course, is to span multiple regions, and that's what the music project focuses on. Okay, so now we are towards the end of the webinar. And what's next? So I would encourage you to read the release notes, and that'll give you details project by project. Upcoming events and releases. Dublin comes out in mid-19, El Alto end of 19, and Frankfurt in mid-20. There's also an event in Paris in January. So I encourage interested folks to go attend that event. And the last slide in terms of what can you do next with Casablanca. So we have 3 suggestions, and these are sort of ARNA specific suggestions. So the first is you can try out ONAP. ONAP is too heavy to try out on a laptop. So that means you have to try it out on a cloud, in a cloud environment, or on a bare metal server. So we have a free ARNA Networks ONAP distribution development. We call it a development distribution. You can try out on a Google Cloud, and we call it Anode 1.0, ARNA Networks ONAP distribution. So you can go to our website, request access to the image and documentation, and within 24 hours, you'll be given access to both, and then you can spin up ONAP on Google Cloud. We also include an OPNFV scenario. So if you don't have your own OpenStack, you can use our OPNFV OpenStack that's included in this distribution. So you'll have a full environment. You'll have ONAP, you'll have OpenStack, and you will be able to try out some of the blueprints. If you want to learn more, I already pointed you to some resources, but you can also try our free ONAP Demystified ebook, and that's available on our website as well. And the last is, if you're ready for ONAP training, we have 1, 2, and 4-day training. Then please make a request, and we will send an instructor to your site and conduct a training. So that's all we had today. There is a chat window, and if you have any questions, you can type in your questions. I'll keep it open for the next minute or so. If there are questions, I'll address them. If not, we can sort of end the webinar. So next minute or two, please feel free to submit questions in the chat window. All right, I don't see any questions, so thank you all for attending, and have a great day. Bye-bye.